Welcome to the MicroMotion How-To video series. In this video, we will cover how to characterize and configure a MicroMotion Coriolis meter using ProLink software. The learning objectives are the following. Know how to check the meter status. Understand how to characterize the meter. Know how to configure the outputs. Know how to save and load the characterization and configuration. For the complete set of configuration instructions, please refer to the MicroMotion Transmitter Configuration and Use Manual. There are many ways to communicate with your transmitter. We will focus on using the ProLink configuration software with a 5700 transmitter in this module. For all configuration tools except the display, you must have an active connection to configure the transmitter. MicroMotion has a variety of transmitters that each have specific instructions for connecting to the transmitter service port. Please refer to the Configuration and Use Manual for your specific transmitter for the complete setup instructions. Connecting the 5700 transmitter with ProLink, we will need a USB-A type cable and connect from the laptop computer's USB port to the USB service port on the 5700 transmitter. Launch ProLink and select Connect to Physical Device. Then select Connect via Guided Connection Wizard. Drag and drop to create a connection between a device, converter, and available COM port. Select the device you want to connect to and drag and drop the device to the signal converter you are using. Select the signal converter and drag and drop it to the PC COM port that is available. Click Next for further settings. Then click Connect. Check the meter for any error conditions that require user action or that affect measurement accuracy. These conditions will be listed on the Alerts tab in ProLink. Characterizing the meter adjusts the meter electronics to match the unique traits of the sensor it is paired with. The characterization parameters describe the sensor's sensitivity to flow, density, and temperature. Depending on your sensor type, different parameters are required. Values for your sensor are provided by MicroMotion on the sensor tag or the calibration certificate. If your transmitter was ordered with a sensor, it was characterized at the factory. However, you should still verify the characterization parameters. First, record the following calibration and characterization parameters from the sensor tag or calibration sheet. K1, K2, D1, D2, FCF, DTC, or sometimes labeled as DT, and FD. Second, using ProLink, select Device Tools, Calibration Data. Third, confirm your sensor type, straight tube meter or curved tube, which would be all sensors except a straight tube meter. Fourth, set the flow calibration factor, also known as FCF or flow cal factor. Be sure to include all decimal points and then click Apply. Fifth, set the characterization parameters D1, D2, DT, K1, K2, and FD as necessary, and apply changes for each parameter that has been changed. The sensor works equally well with flow in either direction. The sensor flow direction arrow establishes a convention of forward flow to accommodate customers who need to be able to define forward and reverse flow for process purposes. The sensor flow direction arrow interacts with milliamp outputs, frequency outputs, and totalizer direction to control how flow is reported by the outputs and accumulated by the totalizers and inventories. Using ProLink, select Device Tools, Configuration, Configure Totalizers. Verify the source and change flow direction as needed. Click Apply and OK to accept all the changes. The search function can also be used to find the Configure Totalizers menu by typing Configure Totalizers. Configure the units for mass flow, volume flow, density, and temperature using the following procedures. For configuring mass and volume flow units, use ProLink and select Device Tools, Configuration, Process Measurement, Flow. For configuring density and temperature units, use ProLink and select Device Tools, Configuration, Process Measurement, and select Density or Temperature. The Process Measurement Units menu can also be accessed by using the search function by typing in Mass Flow Rate Unit, Volume Flow Rate Unit, Density Unit, or Temperature Unit. Mass Flow Cutoff specifies the lowest mass flow rate that will be reported as measured. All mass flow rates below this cutoff will be reported as 0. The same definition can be used for Volume Flow Cutoff. Flow cutoff works in both the forward and reverse direction. The mass flow cutoff should never be set to 0. Refer to your specific transmitter configuration and use manual for proper cutoff value. For configuring mass flow cutoff using ProLink, select Device Tools, Configuration, Process Measurement, Flow, and verify or change the mass flow cutoff as necessary. The milliamp output represents a process variable in proportion to a signal range of 4 to 20 milliamps. First, configure the milliamp output. Using ProLink, select Device Tools, Configuration, I/O, Outputs, Milliamp Output 1. For example, the milliamp source can be set as mass flow rate, volume rate, temperature, density, or drive gain. Second, configure the range for the milliamp output by selecting lower range value or 4 milliamp signal and upper range value or 20 milliamp signal. The milliamp configuration menu can also be accessed by using the search function by typing in MA output or using the Outputs pull-down menu located at the top right of the ProLink screen. Frequency output source specifies the process variable that is reported by the frequency output. Frequency output scaling defines the relationship between frequency output source and the pulse of the frequency output. Scale the frequency output to provide the data in the form required by the device that is receiving the transmitter frequency. This can be completed using ProLink and selecting Device Tools, Configuration, I/O, Outputs, Frequency Output 1. The Frequency Output menu can also be accessed by using the search function and typing frequency or using the Outputs pull-down menu located at the top right of the ProLink screen. Verify or change the following frequency output configuration: source, scaling method, frequency factor, and rate factor. To save the current configuration as either a backup file or a replication file using ProLink, first select Device Tools, Configuration Transfer, Save Configuration. Second, choose Backup or Replicate File. Backup files contain all parameters. They are used to restore the current device if required. The spare extension is used to identify backup files. Replication files contain all parameters except the device-specific parameters, for example, calibration factors or meter factors. They are used to replicate the transmitter configuration to other devices. Third, enter the name for this configuration file and save. To load the configuration using ProLink, select Device Tools, Configuration Transfer, Load Configuration. Select the file that you want to load. The file will begin loading and report when file loading is complete. This concludes the how-to video of Coriolis meter characterization and configuration. In summary, you should now know the following using ProLink software. Know how to check the meter status. Understand how to characterize the meter. Know how to configure the outputs. Know how to save the characterization and configuration. For the complete set of configuration instructions, please refer to the Micro Motion Transmitter Configuration and Use Manual, which can be found on www.emerson.com.